everybody. Okay, today we're going to talk about radicals. This is an extension about what we talked about last time. I'm going to rewrite this so we can see it. Remember that if we have x, some base raised to a rational exponent, I'm sorry, this should be m over n. Okay, so that is, it is some fraction. This is what's known as the exponential form because the fraction is written as an exponent. We saw that could mean two things. Either we could take the base and first raise it to the power m, and then take the necessary root, or we had the power to first take the necessary root, and that will be told by the n. So if n is 3, we'd be taking a cube root, simplify inside the parentheses, and then raise that to the nth power. Okay. So basic examples, if we had x to the 1/2, this is the exponential form. But the radical would then be, the radical form would be x to the square root. And notice we don't put the 2 there, it's understood. And anything raised to the first power is just itself. Or something like x to the 3/4 power, we could write as the 4th root from the denominator of x cubed. And of course the negatives still apply. For example, x to the negative 1/2, the radical form would be 1 over x, well, still the exponential form, but we can then translate it, so now I've made it positive, so 1 over the square root of x. And these are some laws about radicals that you'll need to, if you're putting it on flashcards, put these on. You'll need to know them. Okay. So, for example, what this one is saying, the nth root of some power, some base raised to the same power, will just be a. So, for example, the square root of x squared will just be x. The cube root of a cubed will just be a. Okay. That is, they are inverses, and they will undo each other. Okay. The product rule still applies, that if you're taking any root of a product, it's the same as taking the square root of the first factor times the square root, for example, of the second factor. Right? So the square root of 12 could be written as the square root of 4 times 3, which is the square root of 4 times the square root of 3. And why this helps us is the square root of 4 is 2. And it allows us to simplify radicals. But what this is saying, we've known this, what this is saying is for any root this will be true. So if you're taking a cube root or a 4th root. Okay. Again, the nth root of any product follows the same way. So for example, if we have the cube root of 8 over 27, we could simplify that to be the cube root of 8 over the cube root of 27. And now we know the cube root of 8 is 2, and the cube root of 27 is 3. This 4th example is dealing with radicals within radicals. So let's give an example of that. Sometimes we might want to take like double square roots. And we do this without thinking. So say, for example, I want to take the square root of the square root of 16. Okay. Well, the square root symbol is a grouping symbol, so we would just normally say, okay, I'll keep the outer square root, and 16, the square root of that is 4, and then I could take the square root of 4, which would be equal to 2. What our rule is saying is that the square root of 16, square root of the square root of 16, remember these are 2's, okay, we could take and make that 2 times 2, which is the 4th root of 16. So we'd be looking at the 4th root. Now 16 is 2 to the 4th. And then using this first law, the 4th root of 2 to the 4th, this is, since there are four 2's in the grouping, will just be 2. And this is a rule that we'd like to be true, but it's actually not. For example, we cannot, if there's a sum underneath here, we cannot simply take it as the nth root of the first and the nth root of the second, because the difference here is addition, where up top we had multiplication. So for example, let's take the square root of 9 plus 16. We know this is the square root of 25, and that this is equal to 5. So to illustrate that this property does not work, you might be tempted to say, well, that's the square root of 9 plus the square root of 16. But now this is equal to 3. We'll bring down the plus, and the square root of 16 is 4. And this would be equal to 7. But that is not what the square root of 25 is. Okay. So just be careful about this.